This program will make sure that you know how to deal with a system of particles that are being accelerated. So here we have a system where we have a 10.5 kilogram block pulling itself and a 9 kilogram block. So the first thing we do is we draw all the forces on the system that are important. So we've got the force of gravity from the earth pulling down on the block. We've got the table pushing up on the block. So that would be a force normal. This would be a force gravity, and we'll distinguish this as force gravity 1. We've got another force gravity pulling down from the earth on this other block. We'll call that force of gravity 2. We've got a force of friction between the table and the block, which will be pointing to the left. Then we have a force tension from the rope on the block and a force tension pulling up on the other block. Okay, when we do this for the entire system, we could ignore the internal forces of tension, and we could ignore the force gravity and the force normal for the block on the table. Those two are going to cancel. So we are left with a net force equivalent to the force of gravity on the 10.5 kilogram block minus the force of friction for the block on the table. We divide this by the total mass of our system. This will then give us the acceleration of the system. If we need to find the tension in the system, then we change it. So we are no longer treating the entire thing as a system, but we're isolating one of the two blocks. If you isolate the block on the table, you now have, according to Newton's laws again, acceleration equals force net over mass. The acceleration will be the same acceleration we had for our system, since this will move with the system. Force net will now simply be the force of tension pulling to the right minus the force of friction pulling to the left, and we'll divide by the mass of just the object on the table. Solve that for force tension, and you've got the tension in the rope.